we're talking about this particular exercise as being a simple transportation model.
Yeah.
And you will set up this one exactly the same as you do with any transportation model that we covered in previous webinar recordings. So the only difference is the cost that you see here in this grid.
Mm-hmm.
What you will have to do is add these values to the cost. So you're adding the unit cost of production at each plant. So if you're talking about, these are the plants,
mm-hmm.
I assume,
mm-hmm.
and these are the destinations. So for this plant, you have a unit cost of $35.50 plus $2.50 for shipping. So you add this value to $2.50, you add $35.50 to $2.75, and you add it to $1.75, and so on and so forth. And you do the same thing for the other one, Louisville, $37.50 plus $1.85. So what I'm suggesting is open this spreadsheet. Once you have this information here, you kind of read this. You're just going to have, I would say, the same information added here. You have some calculations where you could, where you have to add these values. So what I suggest, rather than embed the values in the formulas, the best way to do this is write down this, let's just say $35.50, $37.50, $37.25, and $36.25. Okay? This is pretty much your values for unit costs. So here, what you're going to have is equal this value here plus, what I suggest is once you select this, you just click F4 and you just drag this value over. Now you get the new set of values. You do the same for the rest.
Mm-hmm. So it's just kind of like a blended in. You just kind of blend. You add those in across all those.
That is correct. That's it. This is the set of calculation that you have to do prior to setting up your. Okay, what do I have on hand? Stock on hand, and what do I have as a requirement? I already have the demand as a requirement, so it's already been given. I'm sure they give you the stock on hand. It's already here. The annual capacity.
Mm-hmm.
That's pretty much what you have.
Mm-hmm.
And of course, you do the objective function, and and just like you do any transportation model.
Mm-hmm.
Is that clear?
Mm-hmm. So yeah, they're allocated across the shipping costs right here.
Yeah. If the for C it says $10 higher, so what you're going to have is unit cost.
And you would just add $10 to it.
You just add. That's why I suggest.
Mm-hmm.
I suggest to write everything down here, so it will be easier for you to just write formulas to this plus the $10, and you just mark this as F4, and you just drag this down. It's always good to keep the values outside rather than embed the values like this. This is what I mean by embedding the values in the formula.
Mm-hmm.
When you do like this, this is not the best practice, and I recommend not to do that. Okay?
Mm-hmm.
There is a formula that I'd like you to get familiar with, which is the choose formula. Okay?
Mm-hmm.
And what I mean by that, okay, I think the way you write this down, let me see. There you do. This let me see if that's how it works. See that? This is what we're trying to do here. I don't want to confuse you, but if you want, this is a way you could use choose formula. And what I would do is I can put scenario, and I can put here 1 for now, and just mark it in green. Okay? And when I come here, what I would do is I take this value, it's equal to choose whatever this index value, comma, and for this index value, I'm going to put it F4, comma,
Mm-hmm.
and for that, I would choose this value or this value plus this value. But I have to make everything an F4 except this B3. I don't expect you to do this, but if you want, you can definitely try it. It's really fun. It saves you time. So it's always good to pick up something new, right? So look what's going to happen. So I select this and I drag it down. The values are going to stay the same. But what I did is, if I want to choose this scenario number 1, it will pick up these values. If I change this to 2, look at these values. See how they change?
Mm-hmm.
Because it's now picking this value instead. So let me do it for the next one. Equal, choose, what kind of scenario am I looking at? When I select this, it says 2. With that being said, the first value is this one. The second value is this one. So which one is going to pick?
I'm going to pick the 47.
There you go. See what it does? And then I add, because I want to make sure I add this value, which is the shipping cost. I have to make sure that these are absolute values. And I can just hit F4 and I hit enter. And here you go. I can drag this forward again. If I change this to 1, look at all these values, how they're going to change, all of them.
So what happens when you run solver with that? I mean, it's not going to, it won't toggle if you run solver and resolve it, will it?
Well, these are not the decision variables, remember? You still have to come here and do decision variables and copy the grid and paste it here.
Right.
And then you do the objective function, which is cost, total cost, and then that's pretty much all what goes under transportation. So,
yeah,
at least for now. So you still have to copy the grid as I showed before, and you have to put the sum function and so on and so forth. So this is just a pre-calculation prior to doing anything. Let me give you an example. If I go here See, this is the data, this is the decision variables, and this is the result, right? So in our case here, what we're doing is basically, this is the initial data. We just had to do pre-calculation prior to setting up the decision variables and the objective function. Does that make sense?
Mm-hmm. Yeah, I have it all built. I just have to allocate in the prices across.
Right. So here in the annual capacity, what you would have is these values, 18,000, whatever. But then when you start putting the decision variables grid, like I showed you guys before, copying this stuff, pasting it here, and then deleting what's in the middle, because that will become more of a unit quantity, not a dollar quantity, right? And here, this is going to be a sum. You just start setting up your formulas, right? And then here you're going to have cent, and then you set up your formulas, so on and so forth. And then the objective function, once you set up all the formulas and drag that down, then you set up your objective function, which is a sum product. I'm not going to go through all the details because I'm not.
Yeah, no, I'm
here. But that's pretty much how it goes. You know, this is how the transportation is set up. So what I meant is there is another stage to this, which is just basically adding the unit cost of production to the freight cost or transportation cost. And then once you have that grid put together, you take it and you set up the array for the decision variables, and then you set up your solver with its own constraints and use the simplex LP as a method, and then you run. So this is a cool formula. Choose. That's what it does. If you don't want to do this using this formula and it's more confusing to you, all you have to do, like I said, is take this freight cost plus this value here, which is the unit cost, and hit F4. So that way you can drag it across. And you do the same thing here. Equal this value here, the freight cost for Louisville, plus the unit cost of production at Louisville, hit F4, then drag the formula across. This is simple Excel stuff. You do the same thing for Detroit, Phoenix, and then once you want to run this for section number C of this exercise, then you will have to change the values again using this unit cost. So that's pretty much what you need to be doing. Make sure you put your values for the annual capacities. They already gave you the demand. The demand here, see, it says 5.5, 11.5. This is supposed to be 5,500, not 5.5. Okay? The demand is in thousands, not in 5.5 units. So let's correct that. I should probably put it in the announcement as something that needs to be corrected. Well, it kind of does say that in some way. It just has that, the point, whatever, I don't know what is that decimal in there. So
yeah,
11,500, 10,500, 9,600, so on and so forth. All right. So enough talking about this particular one. I think it's straightforward. Even those who kind of forgot to add the unit cost to the freight cost, sometimes I don't take too many points, as long as the setup is done correctly. But why lose some points when you can get it all, turned in 100% correctly?
Mhm. And I guess that was my, this is just one of the questions, but like the clarity on that. I mean, going through the exercises, the going through the chapter, going through the resources, it really didn't. I guess you should just know to allocate it across. And that's where, in Module 2, I kind of hit the roadblocks of doing some of the objective functions with the blended, with the one on 114 and stuff like that, I guess the clarity of it. So I appreciate you taking the time to explain that. So.
No problem.
And I hope we can go over the other problem in detail, because that one is got me 3.8. I just, if you could go over that, if anybody else wants to go over that one, but that one just seems.
Okay. So let me see what others would like to go through before we can jump on it. I know I had an email from someone who couldn't join today. He asked to cover 3.8. You mentioned 3.8, so that's something that we definitely can go over. Are there any questions of what we covered so far? I see Rebecca, Sarah, Stephen. Okay, so 3.8. And that is the yield gain, is that correct?
Yeah, the college.
Okay. Well, I'm sure you all go through the announcement page and you scrutinize everything I provide to you, correct?
Correct. For me.
That's good. So what I suggested looking at is this model. This model here that you can find in the link I provided to you. Remember, let me kind of show you how to pull this up.
Mm-hmm.
I probably have to log in and everything. Okay, just bear with me 1 second. I'm going to pause the sharing and just log in very quick. All right. What do you find to be a problem with that exercise? What is it that you're struggling with?
Well, I pulled off the Invest tab, and it's just I'm looking at the IO. It looks like the initial. It looks like the objective, but then I guess how you come up. I guess the A1, A2, A3 is all the years, but then it goes into B3, B5, C1, D1 on the decision variables, and then going into the interpretation, just kind of understanding around the interpretation. So for me, it's the decision variables where you come up with the A1s through A8 and B1 through B5 and C1 to D, and then the interpretation on the bottom, if you look on the Invest.
Okay. So, sure, I definitely understand your question. So when we look at the exercise 3.8 in the announcement page, I hope you can see my screen. It says that you need to check Chapter 3 Invest tab, which can be helpful in setting up this exercise. So when I click on Chapter 3, it pulls up an Excel file, hopefully. Once you open that file, it will look something like this. Yeah, it's already open. So once you go to Invest tab, you should be able to see this kind of investment problem. This is pretty much exactly identical to the one in 3.8.
Hmm?
The only difference are, can somebody guess?
Well, it's the difference. I think the difference are the rates.
The rates. See these rates here? Those are going to be different. And what else is going to be different with this exercise?
What's the investment at the bottom as well, the interpretation?
Yes, it would be the cost for each year at the college, or whatever, if it's college or investment on the stock market. This is more of a college, I think, investment.
Mm-hmm.
So the tuition might be a little bit different than 24,000, 26, 28, 30. Okay? These are the things that you will have to modify in this model in order to run Solver and generate the answer. So that kind of gets you to get the final answer quickly. Now let's get to understand the concept of this investment problem. When we discuss the investment problem, it's more like we're talking about yield gains, as we mentioned. And with the yield gains, money tends to fall under that category, as being explained in the textbook. Now, when you look at this particular model, let me pull up some of the information from the exercise, 3.8. And but rather than going here, because it says revisit the college expense planning network example of this chapter. So what you need to do is go back to 3.6. And once you click 3.6, there is models with yield gain. This is the section where the textbook starts talking about yield gain. Once you read through this, it gives you a good understanding of what's going on. Let's open this spreadsheet. Open table spreadsheet. Let's copy this information. This is important information in order to understand this particular exercise. I'm going to paste this here. And I'm going to just resize. All right. So what are we looking at? Just move it down here. All right. What are we looking at? We're looking at three types of investments. Each one has its maturity return, and this is the rate of return for each investment account. If you invest in account A, there's 6%, there's 4% return, 18%. So that is the interest rate that you're gaining by investing in these accounts. Now, when you invest in this account, it matures at an annual basis. This is every 2 years, this is every 3 years, and this is every 7 years. Okay? So rather than looking at this more in numbers, it's better to kind of put things visually using the network concept. So this is kind of one way to generate this. This is using the symbols, drawing tools in Excel, and this is where you can find these tools. So as you look at chapter 3, there is this money 3 where you could pull up some of these symbols and use the same concept. Now, I don't think I want to look at this now. I would like to look at the one in the chapter. And this is the one I'm interested in. All right. So what are we saying with this network flow? What we're saying is, you see this A1, A2, A3, all the way to A7 and A8. Because it's an annual basis, this is the investment in year 1, year 2, year 3, year 4, year 5, year 6, year 7, and then year 8. Where for account B, I'm going to always refer back to this table. For account B, you're doing it every 2 years. That's why you will see the arrow jumping and skipping one node and going every 2 years. There's B1. This is the yield gain in the second period and the third period, and so on and so forth. For C1, same thing. You skip 3 years. So this is at a 3-year level, you gain 18%. And for D, 7 years, so you go from 0 all the way to 7. with 0 being today. This is today. This is starting now. Okay? So count this as now. This is the initial investment. This is at the end of year 1 and the start of year 2. This is what this node is. This is basically the same time where it ends here, it starts here. This is pretty much the same exact thing. So what we're saying is whatever we would put as whatever is inflow is going to equal the outflow. This is the concept of conservation. But for the yield gain, we have to account for the interest. So all we're doing is accounting for the interest, but at the end, they all have to equal out. So what we're saying here is whatever we have to put as initial investment has to equal what we invested in accounts A1, B1, C1, and D1. Let's look at it from linear programming standpoint. Are you following me?
Mm-hmm.
Okay. Whatever we invest, this is how it's written. Whatever we invest in the initial investment has to equal to, see this is a negative sign,
Mm-hmm.
and these are positive signs. The reason why? Because we're writing it this way. A1 plus B1 plus C1 plus D1 has to equal to I0. If we take the exact same thing, I'm just going to make a modification here, and take that I0 to the other side, it would be like this. The formula becomes like this, correct? All we did is we deduct this side by minus I0. Here, minus I0, it becomes, so this formula is exactly like this formula. Isn't that correct?
Mm-hmm.
Okay. So what are the coefficients on A1, B1, C1, D1, and I1, or I0? The coefficients are 1, 1, 1, 1, and minus 1. Okay? A1 is positive. It's like we have 1 times A1, 1 plus 1 times B1, plus 1 times C1, plus 1 times D1, minus 1 times I0 equal to 0. That is exactly what you see here. So at year 0, we have, for the initial investment, we have minus 1. For the rest of them, we have A1 is going to be 1. Skip everything, B1, C1, D1, and then 0. Does that make sense?
Kinda.
So, again, remember the concept of inflow equal outflows. Okay? The only difference with yield gain is you have to account for whatever yield gain you generated, whether it's interest rate, it could be interest rate, it could be anything. This is how much it increased the outflows by. So anyway, let me take this off. Let's look at the next year. Let's not stick with 1 year because that might be confusing. Let's look at the next year. What I will do is I go to A2. How many arrows for year 1? How many arrows are coming in and how many arrows are going out?
2.
1 is coming in.
All right, 1.
And 1 is going out. This is exactly what you see. Oh, sorry. This is what you will see here. The only 2 that will be turned on is A1 and A2. The rest are zeros. This is pretty clear, right? that matches the diagram. A1 and A2. A1 and A2. Okay? What do we put for A1? If we take A1 multiplied by the interest rate of 6% or 1.06, has to equal to A2. Does that make sense?
Mm-hmm.
In another way, you could write this down as A2 minus A1, A1 times 1.06 equal to 0. This is exactly this. Same thing. Right? Simple algebra. So the coefficients on A2 account is 1. The coefficient of A1 is 1.06, 1 or minus 1.06. This is what you see here, minus 1.06 for A1 and 1 under A2. I have to make sure that you all understand this. Still not clear?
Well, this is going to be decided by Solver is going to set this up, would it not?
No, this section is not set up by Solver. It's set up by you. Okay? So anyway, if you want to look at the pattern and not have to worry about the concepts behind it, just look at this. The first year, what you're going to see is a -1 always under I0. And then A1, B1, C1, and D1 will have a 1 associated with them. This will be a subproduct of this array times this array. And that will have to equal to 0. So 0, 0, 0, everything equals out. Until you get to the year when the tuition is due. So you will have to pay $24,000 here, and every year it adds up, or it adds another $2,000. So $26,000, $28,000, $30,000, and these have to be negative values. The reason why they're negative values, because if we look at this here, this arrow, anything that you see for these arrows here are pretty much negative values. Same thing as you see for I0, these values will be also negative. The other values that will be negative are the ones on the left side. See, this side here, A1 will have a negative coefficient, where this one will be a positive coefficient. This, on the next year, there will be a negative coefficient. This will become a positive coefficient. Look at this. Minus 1.06. Then this was A2 for the year number 1. It was 1. Then it becomes 1.06. Then it continues this pattern. Because there's a yield gain every year of 6% for this account A. When we start talking about account B, you'll start with a 1, and then 2 years after you'll gain 14%. And then 2 years after you gain 14%. Then 2 years after you gain 14%. Same thing with account C. You'll gain 18%. After 3 years, you gain 18%. You can't go another, 3 years longer because you're going to pass the 8-year time frame where this is all, done. If you look at D1, same thing. After 7 years, it will be, a gain of 65%. This is pretty much how this is set up. And the reason for these negative and positive, you just have to understand that the inflow times the yield gain equal the outflows. I think I had them somewhat the other way. So yield gain times inflows equal the outflows. And you could see that exactly from this particular one. So if we look at, for example, at year 7, how would you write this? You have 2 arrows inflows, and you have 2 arrows outflows. If we come here, what you see here is A7. A7 is negative. So remember, inflows are negatives, and outflows are positive. Coefficients, of course. Let's remember that. So A7, it would be negative. D1, it will be negative. A7 is negative. D1 is negative. What goes on here is 30. This is the payment that is due. That's going to be written right here. And the sum products will take this, all these values times whatever the solver is going to come up with, and it has to equal out to minus 30. That's why you see this minus 30 at the end. So this represents D1, this represents A7. A7 and D1. So once you have the network diagram set up prior to setting up your constraints, I think that will help alleviate some of the complexities that you see here. And why is 1.06? Like I said, the rule is yield gain times inflows equal the outflows. What that means is the yield gain for 8 accounts is 6%. So automatically you're going to write 1.06. And then you're going to ask, is this an inflow? If it is, then it's a negative. Okay? Then you come to the account D. And you say, okay, D is an inflow, so it has to have yield gain times inflow. So the yield gain is 65%. So automatically you're going to write 1.65. And since it's an inflow, it's a negative number, so minus 1.65. Does that simplify it?
Mm-hmm.
For the outflows are going to be positive. That's why you see a 1 here for A8. A8. You see a 1. And then for this value, you'll see it right here for the right-hand side, and then here will be a formula for the sum product. That is the logic behind this. So A1 through A8, because you have to include the A8, which tells you that you want to confirm that the remainder is 0. That's why you go 1 year past A7. And then for these ones, you do B1, B3, B5. You can't do B7 because that would take you another 2 years. So you omit that. For C1, C4, you still keep that, and for D1, you keep that one. This is the reason why we didn't include B7, because B7 lasts 2 years and it goes past the 8 years time frame, because that's what the exercise is asking for. It's telling us within the 8 years they want to know whether the investment is right or wrong. And here you go. If you read this portion on yield gain, I think it will explain to you exactly what all of this means. You have to really read it carefully in order to understand how to set this up. So what we're doing is, when we set up the constraint, we're taking the coefficients and we're plugging these coefficients into our constraint. I know it can get difficult, but once you do it twice, multiple times, it will start getting clear for you. Let me see if there are any further questions on this one. If you have any questions or you feel a little bit okay, then that's good. Because it's hard to explain this within a 30 minutes time frame. That takes a little bit more of explanation. That is correct. Okay, let's see if there are any other questions before we move to that interpretation at the bottom, because that interpretation at the bottom is not required, I believe, from the exercise. The only thing required is that top portion. And Stephen is referring to this interpretation right here. Let me get rid of this. So my suggestion for this particular exercise is go to chapter 3 in that link I provided in the announcement page. Once you click this, you can open and go to that sheet called Invest, and all you have to do pretty much is change the rates and change the values here and run Solver. And that will pretty much give you the minimum initial investment. That's what you're going after. How much money do I invest? Minimum investment. By distributing these money to these different investment accounts at these different rates with these availabilities and maturities, it will still meet the expenses of my child going into college and be able to fulfill all the requirements for college tuition. The fulfillment that you need to achieve, let's say here, is almost $108,000. I know school is expensive, but just doing some prior optimization and kind of doing some planning and prep work, you can actually find ways to overcome this particular issue. $108,000 across 4 years. This person is doing planning ahead of time, 4 years prior. So they're starting with $74,422, and that's what the solver came up with for that individual to do pre-planning for their children as they getting into school, or as they have 3-4 years prior to getting into college. So they're doing this probably in the middle school. And what they did is they invested this amount of money in account A in year 5. They invested in B first year in the account B. And they invested in, after 2 years, they invested $64,114. And let me see. No, what I meant is they invested $74,422, and that investment kind of was distributed in some sense right here, as you could see with the diagram. That initial investment, it went to account B, and account B, from account B, it generated some money. That money was taken and plugged into account A, and some of it stayed in account B. You see how that happened? So this person is taking money out of a certain account, plugging it into another account, and that is how they managed to optimize their investment to fulfill a $24,000 and a $26,000 and a $28,000 and $30,000 tuition each year. Pretty neat. I don't think you would be able to configure such thing just by looking at it.